Hi, hello everybody. First of all, I would like to express my pleasure being a participant in this conference for this second time. And also I would like to thank all the organizers of the conference. Let me first introduce myself. My name is Riham Nady. I'm an associate professor at the Department of Architectural Engineering, Faculty of Engineering, Faroes University in Alexandria, Egypt. My paper is talking about the impact of passive design strategies on cooling loads of buildings in hot climates. Analysis of performance in ICCAUA2022EN0026 Egypt. Let's have a short background about the topic, that in the previous few decades, climate change has been a highly essential problem to consider while dealing with the design of buildings. Thus, passive design adjusts to the local climate to promote thermal comfort conditions for building occupants while reducing energy consumption and lowering building temperatures. This emphasizes the importance of identifying and adopting passive cooling solutions that can be used in buildings, particularly in hot climates, to develop the user's thermal comfort. The main problem is that the built environment accounts for from 30 to 40% of the total energy consumption due to heating and cooling demands. In other words, there has been a tremendous growth in the use of air conditioning systems and mechanical methods for cooling buildings across the world, and particularly in hot arid climates. The paper has several objectives. Number one, examining the fundamental challenges that face passive design to achieve thermal comfort in the built environment. Number two, highlighting the importance of promoting passive design techniques and control principles that can be recommended for use in hot climate. Number three, comparing between the various passive cooling strategies to reduce energy consumption and improve thermal comfort in a building in hot environments such as ICCAUA oasis. Number four, presenting the findings of the simulation and climatic recommendations using passive design approaches that can be applied in hot arid regions. Number five, identifying the effective cooling strategies as a proposal for promoting thermal comfort conditions and minimizing cooling loads inside buildings, particularly in hot areas. The research will be discussed as follows. First of all, the problem, as we have stated before, is the stress of cooling loads in buildings in hot arid climates. Then the second part is the literature review that deals with different features of passive design and thermal comfort in hot regions. And then part three is the case study that proposes a design of a culture center in ICCAUA oasis. In the case study, there was a methodology that was adopted according to the following steps. First, the selection of light stanza simulation software, then modeling and analyzing the case study without passive design techniques, and then modeling and analyzing different cases after applying passive design techniques, and then a comparative analysis or a comparative study between the different cases, until we reach the results that evaluates the thermal performance of each case, to reach the conclusion which is deciding the best passive design strategies for buildings that can be adopted in buildings during the design stage. Let us see the relation between passive design and thermal comfort in the built environment. Passive design is a type of architecture that uses climate and natural elements to provide a suitable temperature within the building to eliminate the dependence on mechanical systems for cooling, heating, and lighting. Thermal comfort influences an individual's ability to function as well as their health and depends on the accommodation of building design with the outdoor climate. Thus, there are two main factors that affects passive design: climate and comfort. Climate, of course, varies from one region to another in different parts of the world. Then each region has its own design and construction techniques. Comfort has been driven by a need for energy efficiency in the building sector without compromising long-term health and well-being of its occupants. So if these two factors are applied in a good way, then it will result in a satisfying built environment. There are different passive design solutions that can be adopted or that can be applied in hot climates, such as the orientation of the building, which is the process of orienting the building to take advantage of the sun's free energy to reduce the overall building's energy consumption. In hot, dry climate, the optimum orientation for long facade is to face north and south and to be towards the prevailing cool wind direction. Building form and massing, which is related or considered with the shape of and size of the building to maximize its free energy from the sun and wind and minimize energy loads. In hot, dry climate, the form of the building should minimize east and west walls. The building envelope is considered with the different parts of the building, such as walls. The color of the building envelope affect the thermal performance and reduce indoor temperatures. Also the roofs, insulation is placed on the roofs so that the thermal mass is weak with the external source and strong with the interior. And the openings, proper window placement ensures optimum quantity of sunlight to enter the building and achieve natural ventilation. The choice of materials is an important factor and is employed in the building to reduce the heat gains inside the building. Thus, the use of available local materials reduces energy consumption and consequently building costs. Vegetation and greenery is another effective mean of moderating the temperature surrounding a building and reducing its cooling requirements, such as trees, climbers, high bushes, and ground cover by plants. All of them reduce the amount of reflected solar radiation that reaches the building. Enclosed courtyards is another considerable impact on the local climate and contributes to the improvement of the environment. Courtyards reduce the cooling energy needs in buildings by collecting cool air at night and providing shade during the day. Water bodies is very effective, especially in hot, dry climate, where it uses the sensible heat of air to evaporate water, thereby cooling the air, which then cools the interior spaces. The presence of a water body in a courtyard can provide a cooling effect. Wind towers is another solution because it is a shaft that extends above a building's roof with openings towards the prevailing winds. This results in adequate ventilation and low indoor temperatures that keeps the occupants cool without the use of the energy. The case study is a proposed design of a culture center in Siwa Oasis, Egypt. Siwa is a very small town located in Egypt's western desert and is situated 12 kilometers east of the Libyan border, and it has a distinct architectural style in construction, as we see in the pictures. It has a total area of 1,088 square meters, populated by 11 traditional tribes, and it has 300 springs. Siwa has a hot, dry climate. Most of the year, the temperature exceeds the comfort zone. During summer months, from June till August, the maximum temperature exceeds 40 degrees Celsius. In spring and autumn, the temperature reaches between 32 and 39 degrees Celsius. The main problem in Siwa Oasis is the high temperatures, and thus people have relied on the use of mechanical cooling systems all the year to improve the indoor thermal performance. Thus, it was proposed to apply different passive cooling design techniques on the proposed building. The building is designed as a compact structure composed of 4 wings that are connected with each other through a central open courtyard. The building contains different functions such as administration, mediatheque, library, music conservatory, training rooms, a theater, a restaurant, and a kitchen. After that, this phase regards the development of the 3D model of the building using light stanza simulation program to assess the effects of applying passive cooling techniques to accommodate the thermal comfort inside the building. So I have tried different cases like orientation of the building, and I tried it before and after applying the passive cooling techniques. The simulation was carried out during January and July, a month in winter and a month in summer, to see the difference between both seasons. I have also tried in-depth windows with slope seals, windows with sunk screens and louvers, different size of openings, different situations for the courtyard, once with a fountain, another with vegetation, the other with a shading device. And then this resulted that the reference case simulates the worst condition during the absence of passive cooling strategies, which resulted in significant heat retention of the indoor areas. However, comfortable indoor temperatures were achieved by the proper use of passive design strategies, including building orientation, form, envelope, courtyard shading devices, and applying fountains. Thus, this resulted in that case 1, the orientation, it was observed that the building orientation has a cooling effect in January than in July. Case 2, in-depth windows with sloped seals. The recessing and sloped windows control the entry of solar radiation into the spaces and reflected on the outside of the building. Case number 3, windows with sunscreens and louvers. It was proved that the sunscreens on windows are effective in the months of summer than in winter, as it prevents the building from direct solar radiations and enhances cross ventilation. Case number 4, size of openings. The different sizes of windows plays an important role in natural ventilation inside the spaces and consequently reduces the cooling loads on buildings. Case number 5, the courtyard with the fountain. The fountain enhanced the evaporative cooling, especially in summer months. Case number 6, courtyard with the vegetation. The green plants in the courtyard protected the building against extreme heats of the summer. And finally, case number 7, courtyard with a shading device. This proved to be the most cooling effect, and it is considered as a good solution for air ventilation and decreasing the temperature inside the building. This leads to the conclusion that after applying all the previous passive design techniques, it was observed that they achieved functional, sustainable solutions lower cost and increases building performance, also serving as a tool to achieve sustainable strategies to develop the cooling loads in hot, dry climates. It was concluded that form and orientation play an important role in using passive cooling techniques. Building envelope is the most influential parameter to the indoor thermal comfort. Placement of windows in east and west direction, as well as wind resistant slope, generate cross ventilation in interior spaces. Local vegetation protected from dust storms and ensure shadows to gain natural ventilation. And finally, local available materials create low-cost buildings and preserve local identity of the city. Thanks so much for your attention.